Assalamu alaikum. My name is Zaim Khan and I'm going to discuss the method of development of HPLC. HPLC stands for High Performance Liquid Chromatography. There are some steps for the development of high performance liquid chromatography. Step number 1, the selection of HPLC method and initial system. Step number 2, the selection of initial conditions. Step number 3, the selectivity of optimization. Step number 4, system optimization. Step number 5, method validation. Step Depending on the overall requirements and nature of a sample analyzed, some of these steps will not be necessary during HPLC analysis. The following must be considered when developing an HPLC method. Number 1, keep it simple. Number 2, try the most common column and stationary phases first. 3, slowly investigate binary mobile phases before going on to ternary. 4, think of the factors that are likely to be significant in achieving the desired resolution. Now, method development. Step number 1, selection of the HPLC method and initial system. When developing an HPLC method, the first step is always to consult and literature to ascertain whether the separation has been previously performed, and is so, under what condition. This will save time doing unnecessary experiment work. When selecting an HPLC system, it must have a highly probability of actually being able to analyze the sample. For example, if the sample includes polar analytes, then reverse phase HPLC would offer both adequate retention and resolution, whereas normal phase HPLC would be much less feasible. Reverse phase is the choice for the majority of sample, but if acidic or basic analytes are present, then reverse phase ion separation or reverse phase ion pairing should be used. The stationary phase should be C18 bonded. For low and medium polarity analytes, normal phase HPLC is a potential candidate, particularly if the separation of isomers is required. Cyano-bonded phases are easier to work with than plain silica for normal phase separation. For inorganic anion cation analysis, ion exchange chromatography is best. Size exclusion chromatography would normally be considered for analyzing high molecular weight compounds. 2000 nearly. Gradient HPLC is only a requirement for complex samples with a large number of components, 20 to 30, because the maximum number of peaks that can be resolved with a given resolution is much higher than is in isocratic HPLC. This is a result of the constant peak width that is observed in gradient HPLC. The method can also be used for samples containing analytes with a wide range of retentivities that would, under isocratic conditions, provide chromatography with capacity factors outside of the normal acceptable range of 0.1 to 15. Now, step number 2, selection of initial conditions. This step determines the optimum condition of adequately retain all analytes. This is ensured on no analyte has a capacity factor of less than 0.5, and no analyte has a capacity factor greater than 10 to 15. Selection of the following is then required: mobile phase solvent strength. The solvent strength is a measure of its ability to pull analyte from the column. It is generally controlled by the concentration of the solvent with the highest strength for example. in reverse phase HPLC with aqueous mobile phases. The strong solvent would be the organic modifier. In normal phase HPLC, it would be the most potent one. The aim is to find the correct concentration of the strong solvent. With many samples, there will be a range of solvent strength that can be used within the uh, aforementioned capacity limits. Other factors may also affect the overall retention of analysis. Gradient HPLC with samples containing a large number of analyses or with a wide range of analyte retentivities. Gradient elution will be necessary to avoid excessive retention. Determination of initial conditions. The recommended method involves performing two gradient runs differing only in the runtime. A binary system based on either acetonitrile water or methanol water should be used. Step number 3, selectivity optimization. The aim of this step is to achieve adequate selectivity. The mobile phase and stationary phase compositions need to be taken into account. The minimize the number of the trial chromatograms involved only the parameters that are likely to have a significant effect on selectivity. The optimization must be examined. To select these, the nature of the analytes must be considered for this. It is useful to categorize analytes into a few basic types. Once the analyte types are identified, the relevant optimization parameters may be selected. Note that the optimization of mobile phase parameters is also considered first, as this is much easier and convenient than stationary phase optimization. Selectivity optimization is gradient HPLC. Initial gradient conditions should be optimized using a binary system based on either acetonitrile water or methanol water. If there is a serious lack of selectivity, a different organic modifier should be considered. Now, step number 4, system parameter optimization. This is used to find the desired balance between resolution and analysis time. For this, after this satisfactory selectivity has been achieved, the parameters involved include column dimensions, column packing, particle size, and flow rate. These parameters may be changed without affecting capacity factors or selectivity. Step number 5, the last step, the method validation. Proper validation of analytic method is important for pharmaceutical analysis. When the insurance of the continuing efficiency, efficacy and the safety of each match manufacturer release solely on the determination of quality. The ability to control this quality is depend upon the ability of the analytic method as applied under well defined conditions and at an established level of sensitivity. To give a reliable demonstrate of all deviation from target site area, analytic method validation is now required by regulatory authorities for marketing authorization and guidelines have been published. It is important to isolate analytic method validation from the selection and development of the method. Method selection is the first step in establishing an analytic method, and consideration must be given to what is to be measured and with what accuracy and precision. Method development and validation can be simultaneously, but they are two different processes, both downstream of method selection. Analytic method used in quality control should ensure an acceptable degree of confidence that results of the analysis of raw material excipients, intermediates, bulk product of finished products are viable. Before a test procedure is validated, the site area to be must be determined. Thank you so much.